Section 4.5, conditional probability and then complements. So we're going to start with this example again. 2 red marbles, 3 green marbles, and 4 blue marbles are in a box. Suppose that you pick 2 different marbles. That's the way that I would say it. If you pick 2 different marbles, that means that you take one out and you do not give it back. You do not replace it. So if you ever see that where it would say, suppose you pick 2 marbles with no replacement. It means you pick a marble, you get to keep it. Which means that there are now no longer 9 marbles in the box because you got one in your hand. There's only 8 left. So that's an important part of no replacement. Find the probability of getting a red and then a green. So for the red one, this goes first. There's 2 red ones, so that's going to be 2 out of 9. And then means multiply. Now you go for the green. Well, there's 3 greens out of how many? Since we took a red one out, there's only 8 marbles left. So it's going to be the first one, red, is 2 out of 9. Then, since we have a red one in our hand, there's only 8 marbles left. And 3 of those are green. So then you just divide 6 divided by 72 and get this lovely decimal point 0.083. So how does that differ from getting 2 reds in a row? Well, the beginning of the story is going to be the same because the first one's red, so it's going to be 2 out of 9. You're then holding a red one in your hand, so there's not 9 marbles left, there's 8 marbles left. Then this part is going to have to be how many reds are left. Well, if there were 2 and you're holding one in your hand, there's only 1 left. So in this case, the top is going to have to count down 2 to 1, and the bottom 9 to 8. So that changes our answer to be 0.023 or 2.3%. The next definition is the conditional probability. So what this vertical line right here means is that event A has already occurred. So it's asking you find the probability of B given that A has already occurred. So for example C, find the probability you get a green one given that somebody already drew a red. So if somebody already drew a red, that means there's only 8 marbles left. And since we're starting all over, there are 3 green ones out of 8, or 37.5%. Next, the example with gender combinations. This couple is now going to have 4 children. What's the probability they have at least 1 girl? So one way to do it is you write out all of the possible gender combinations. Here they are. So here they are having 4 boys. Here they are with 3 boys and a girl, but then the girl could be the last child, the 3rd child, the 2nd child, or the 1st. And then in here you have to be sure you get all of the combinations where there's 2 boys and 2 girls. There's 6 there, etc. Then the question is asking, what's the chances they have at least 1 girl? Well, all of these are the cases where they have at least 1 girl. So that's 15 out of the 16 cases. So the answer is 15 out of 16. 15 divided by 16. But we need a faster way than that. I mean, I can crank these tables out pretty fast because I've been doing this for 20 years. But if you haven't, it may take a while to make sure you get all the different gender combinations, and then you've got to count, etc. So we'll do it using the variable x. So we'll let x be the number of girls, since that's what the question is asking it for. It's asking about girls. X is going to be the number of girls in the family. Sorry. Okay, sorry about that. A little review. So the question was asking, find the probability x is at least 1. Well, if x is at least 1, that means they could have x equals 1 girl, or 2 girls, or 3 girls, or 4 girls. Which, if we're going to do a formula 4 times, or whatever the process is, 4 times, that's going to be a lot of work. Instead, we could use this. You could use the rule for complements. The probability of something is equal to 1 minus the probability of the opposite. Then what is the opposite of at least 1? So in other words, you don't even have at least 1. If you don't have at least 1, then you've got 0 of them. So x equals 0. X is the number of girls. So if x equals 0 girls, that means all 4 of their kids are boys. What are the chances of that? Well, to be a boy, there's a 1/2 chance. If they do that 4 times in a row, you raise it to the 4th. And this 1 minus has just been sitting there all along. Finally, you do the subtraction, and you get 15 out of 16, the same as last time. But this method can be used for a lot of different things, not just gender combinations. For example, 4% of light bulbs are defective. There's a batch of 12 that are tested. What's the probability? At least 1 is defective. So we're going to use the variable x again. Since the question is about defective, then we should let x be the defective ones. So we start off just the same. The probability of something is equal to 1 minus the probability of the opposite. The opposite of at least 1 means 0. Now x stands for defective. That means none of them are defective. So what's the chances none are defective? Well, if they're not defective, there's a 96% chance because there's a 4% chance of being defective. So there's a 96% chance of being not defective. Now, if I just left out the 96, that's only 1 that's not defective. Sorry, this is not supposed to say to the 4th. This is supposed to say to the 12th because we've got 12 light bulbs. And so the final answer is 0.387. So this should say, this right here should say 12.